Hello everyone and welcome back. My name is Mr. Kowald, and in this video I'm going to be going over how to calculate the value of an equilibrium constant from equations that are given to you that you can manipulate and refer to like other equilibrium constants. So let's get into this. Okay, so for this video we're going to do NH3 plus H3O plus. The hydronium ion is in equilibrium with NH4 plus and H2O. So in this problem, they ask us to calculate the value of the equilibrium constant for this reaction. But we're also asked to classify the reaction, like what kind of reaction we have here, and determine whether the final concentrations of this reaction should be found by treating this reaction as an equilibrium problem or as a stoichiometry problem. So let's get into this. Okay, so here, this is our equation. So the first thing you should recognize is that it looks like we have ammonia reacting with hydronium ion, or H plus, and that's giving rise to the ammonium ion and water. But if you look carefully, you'll notice that this is the reverse of the reaction of the conjugate acid of ammonia with water. So if you look here, we have the conjugate acid of ammonia. So this is ammonia as a base, this is the conjugate acid, and this is reacting with water. So if we take the reverse of that, we get NH4 plus water in equilibrium with NH3 plus H3O plus. Okay, so now it's clear we have an acid reacting with water to form a base and the hydronium ion. And this reaction fits the definition of what we call the Ka value, or the acid dissociation constant, or simply put, it's the equilibrium constant for acids. So we want to know what the Ka value is for this. And again, the definition of the Ka value only fits with reactions where you have an acid reacting with water. So this has a Ka value, an A for acid. So we're looking for the dissociation constant of the acid reacting with water. So if we could find this, and this K constant, or this reaction here, is the reverse of this reaction. And if we remember that the K values, the equilibrium constants of reactions, are related to each other in a certain ways. So if we took the reverse of this, then we know that the Ka value of this is the reciprocal of the Ka value for that one. So if we could find the Ka for this one, we just need to take the reciprocal of it, and we've got our answer. But the thing is, you can't look up the Ka value of ammonium ion. You're not going to really find it in a table. However, we do know the Kb value of ammonia. That you can look up in a table, right? So the Kb value, again, just like the Ka value, the Ka value is the value, the equilibrium constant specifically for an acid reacting with water. The Kb value is the same for bases. So the Kb value is the value, the equilibrium constant for when you have a base reacting with water. So here, if we write NH3 reacting in water, which is H2O, not H3O, in equilibrium with the hydroxide ion. So let's write this NH4 plus. So the ammonia is going to take a hydrogen from water, and that's going to form the conjugate acid ammonium plus the leftover hydroxide ion. So this does have a Kb value associated with this, and this we can actually look up in a table somewhere or on the internet. So if we look up this value, we get 1.8 times 10 to the negative 5. So this is 1.8 times 10 to the negative 5. So since we know the Kb value, we can actually find the Ka value for the conjugate acid ammonium. Well, how do you do that? This nice equation here. So the Kw is equal to Ka of the acid multiplied by the Kb of its conjugate base. So if we could solve this, and we could solve for Ka. So Kw, this is equal to 1.0 times 10 to the negative 14. So Kw is equal to Ka times Kb. Since we know Kb here, so then it's going to be Ka times the Kb of the ammonia, which is 1.8 times 10 to the negative 5. So all we have to do is divide both sides. So we have divide by 1.8 times 10 to the negative 5 here. Divide by 1.8 times 10 to the negative 5 here. And so then we get Ka for the ammonium is going to be 5.56 times 10 to the negative 10, I believe. Yes, 10. Okay, so now we have the Ka value. So here we have the Ka value. But that Ka value is for this reaction here, the conjugate acid reacting with water. But what we want to find is the reverse reaction, where you have ammonia plus the hydronium ion giving you ammonium plus water. So as I said here, the K value for this reaction is going to be 1 over Ka. Well, we just found Ka, which is right here. So all we have to do is plug that in. So let me get rid of this. So the K value for this reaction, this is our target reaction here. The K value for that is going to be 1 over the Ka value that we just calculated here. So that's going to be 5.56 times 10 to the negative 10. So K, the equilibrium constant for this reaction then is going to be 1.8 times 10 to the 9th. So that is the K value for this reaction. And so now we can go ahead and answer the other question. So we want to classify this reaction. Well, here we have a weak base, and the hydronium ion here is usually associated with a strong acid like HCl or HBr or something like that, right? So because the reason for that is because strong acids will dissociate, or I should say ionize, completely in water, and so you can represent that merely by the hydronium ion or H plus concentration. So here this would represent a strong acid reacting with a weak base. So yeah, that's the type of reaction you have going on here. So it's a weak base, strong acid neutralization reaction. And then the other thing we're asked is to determine whether the final concentration should be found by treating the reaction either as an equilibrium or stoichiometry. Well, let's look at the K value here. So here the K value is very, very large. So basically this means that the equilibrium lies very, very close to the product. So it favors the products very, very heavily. So this is pretty much going to go to completion. So we would treat this as a stoichiometry problem for that reason. And so that's how you answer this question and do this problem. I hope you enjoyed the video. I hope you learned something from this video. If this helped you out in any way, then please, by all means, like the video, share the video, hit that like button right there. Also, subscribe to my channel, hit that notification bell up above. When you do that, click all so you can be notified by all the videos I put out. And finally, put a comment down below in the comment section. Let me know what you think. Ask me questions. I would love to hear from you. Thanks for joining me. Have a great day.